Good morning, children. So now we'll continue with the problems. As you have already solved some problems where you find the angle between two lines cos theta formulas a1 a2 plus b1 b2 plus c1 c2 by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. So even these problems are based on that. So the vertices of a triangle are given. Find the angles A, B and C. That is one problem. So these are also very important for 7 marks. Another problem is you are given again the vertices and then find the direction ratios of the sides. Then determine whether it is right angled or isosceles. So like in first problem, here also you will find out all the 3 angles. If 2 angles are same, then you will say that it is isosceles. If you get one angle as 90 degrees, you will say that it is right angled. So you will find out whether it is right angled or isosceles by finding all the 3 angles like in first problem. So you can try the second problem and do the first one. So these are on page 149 in the textbook, 3rd section, 6th and 7th problems. So I'll do the 7th problem solution. So in the 6th problem, you take the vertices as A, B and C letter. So let A is equal to 1, 4, 2, B is equal to minus 2, 1, 2 and then C is equal to 2, 3, minus 4 be the vertices of triangle ABC. Be the vertices of a triangle ABC. Now you must find the angles between angles A, B and C. So A is the angle between AB and AC. A is the angle. This is the angle. This angle is between A is the angle between the sides AC and AB. So we'll take AB direction ratios, AC direction ratios and then apply that formula. So DRs, direction ratios of AB. What are the direction ratios? Direction ratios of side AB. Of side AB are x2 minus x1. x2 minus x1, comma y2 minus y1, comma z2 minus z1. So there, if you subtract x2 minus x1, minus 2 minus 1, minus 3, and then 1 minus 4, minus 3, 2 minus 2, that is 0. So you take them as it is like this. Now next is direction ratios of a side AB next to BC. So what are the direction ratios of BC? Same formula. So 2 plus 2, 4 and then 3 minus 1, 2 and then minus 4 minus 2 minus 6. So these are your A1. If you take them as A1, B1, C1 and this as A2, B2, C2 and then the direction ratios of side AC or CA, anyway you can take. So 2 minus 1 AC, so 2 minus 1, 1 and then 3 minus 4 minus 1, minus 4 minus 2 minus 6. So these are A3, B3 and C3. Now if capital A, capital B, capital C, capital A, capital B, capital C are the angles of the triangle, or first we'll write A is the angle between AB and AC. A is the angle between AB and AC. AB and AC. So therefore cos A is equal to what are the direction ratios of AB? A1, B1, C1. Direction ratios of AC, A3, B3, C3. So write the formula as A1, A3 plus B1, B3 plus C1, C3 by root of A1 square plus B1 square plus C1 square into root of A2 square plus A3 square. A3 square plus B3 square plus C3 square. So now find out A1, A3. A1, A3 means minus 3 into 1. Modulus of this. So minus 3 into 1 is minus 3 and then plus 3 plus 0. So we are getting the angle as yes, minus 3 plus 3 plus 0 by root of. So this is root of 16 plus 4 plus 36, and then again root of 1 plus 1 plus 36. So it is equal to 0. 3 gets cancelled and 0. So 0 by any number is 0. 0 can be written as cos pi by 2. So that means A is equal to pi by 2. So one angle we find out. Now in the same way we'll find angle B. B is the angle between what sides? B is the angle between BA and BC. B is the angle between BA and BC. So BA or AB direction ratios are same. So we can write cos B is equal to what is BA or AB, same direction ratios. So it is A1, and for BC it is A2. So the formula is A1 A2 plus B1 B2 plus C1 C2 by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. So now multiply A1 A2 means minus 3 into 4 minus 12 and minus 6 plus 0 by root of 9 plus 9 plus 0. AB and AC. Root of this is correct, 1 plus 1. This is wrong here, please. So here actually it should be 9 plus 9 plus 0, but anyhow it is 0, so okay. So 9 plus 9 plus 0 into root of A2 square cos B, A2 B2 C2. What is A2 B2 C2? So 16 plus 4 plus 36. So you will get minus 18 by mod. When you take modulus, it becomes plus only. So 18 by root of 9 to 18 into root of 40, 56. Root 56. So 1 root 18, you can write as root 18 into root 18. And 1 root 18 gets cancelled, and it is root of 18 by 56. So 2 9s are 18. So root of 9 by 2 8 is 16. So root 9 is 3. 3 by root 28 can be written as 4 7s are 28. So 2 root 7. So like this you can do. So therefore cos B is equal to cos inverse of 3 by 2 root 7. So this is one answer. Now C is the angle between I'll write it out. So C is the angle between CA and CB. So cos C is equal to CA or AC is this. CA and CB means this. So the formula becomes A2A3 plus B2B3 plus C2C3 by root of A2 square plus B2 square plus C2 square into root of A3 square plus B3 square plus C3 square. So that is equal to A2A3 means 4 minus 2 plus 36 by root of BC. So root 56, that is root 56 and AC. AC is 36, 37, 38, root 38. We'll get like this. It is root of 38 into 38 by 56 into 38. 138 gets cancelled. And then when you simplify it, when you cancel 2, it becomes 19 by 2, 2 is 4, 2, 8, so 16 like this. So that means cos C is equal to this, no? So C is equal to, implies C is equal to cos inverse of root of 19 by 28. So like this we find all the 3 angles. Procedure is same, but you are finding the angles 3 times. A is the angle between AB and AC. B is the angle between BA and BC. So accordingly, you just substitute the values and finally you write. Therefore, the angles of the, after this step, you write. Therefore, the angles of the triangle are, we'll write. The angles are, angle A is equal to 90 degrees. Angle B is equal to cos inverse of 3 by 2 root 7. And C is equal to cos inverse of root of 19 by 28. This is your answer. Okay. Now in the same way, you find the angles here in this second problem, and then you can see that one angle, it is right angled, it is not isosceles. In the same manner, you find the 3 angles, then you will get only one angle as 90. The other 2 angles are not equal. So it is not an isosceles. It is just a right angled triangle. So you can try the second bit. Now we'll do the next problem. Now the next problem is show that the points, 3 points. It is again second section, 5th problem. Second section, 5th problem. Show that the points 2, 3, minus 4, 1, minus 2, 3, and then 3, 8, minus 11 are collinear. Show that they are collinear. Are collinear. If you remember, we solved a similar problem in first chapter, coordinates chapter. So how did we do there? There you took the 2 points, 3 points as A, B, C, 2, 3, minus 4, and then B is 1, minus 2, 3, and then C is 3, 8, minus 11. There you found the distances, AB distance, BC distance, AC distance. Then sum of 2 distances is equal to the third distance. If it is satisfied, then the 3 points are collinear. So here you have another simple method using direction ratios. We'll find the direction ratios of AB. We'll name them as A1, B1, C1. What is it? 1 minus 2. So x2 minus x1. The formula is x2 minus x1. y2 minus y1. z2 minus z1. So when you simplify, it is 1 minus 2. That is minus 1. And then minus 5. And then 7. So you get like this. Now write the direction ratios of BC. Any 2 sides, any 2 you can take. You can take ABAC or ABBC or like that. So A2, B2, C2. So we have taken for BC. So 3 minus 1, 2. And then 8 minus plus 2, 10. So it is 10. And then minus 11 minus 3, minus 14. Now you can see, you find out A1 by A2. A1 is minus 1. A2 is 2. And then B1 by B2. If all the 3 are equal, then they are parallel. We proved one property in while deriving the angle between the lines and all. So minus 5 by 10. So this is same as minus 1 by 2. Now C1 by C2 is 7 by minus 14. That is minus 1 by 2. So you can see all are equal. So since A1 by A2 is equal to B1 by B2 is equal to C1 by C2, the lines, actually it should be AB and BC. AB, you have taken AB. So AB and BC are parallel. There we derived the condition for parallel lines. So if the direction ratios are proportional, then they are parallel. But can you have AB, suppose AB here, and B another at some other point and C like this so that they can be parallel? No, B is the common point. So it has to be like this only. So you will say that AB and BC are parallel, implies that the points ABC, according to that it should be parallel, but the points A, B, C are collinear because B is the common point, are collinear because B is the common point, and it has to lie in the same line. B is the common point. They should be collinear. They cannot be a different parallel lines like this. So this is another procedure, another method to show that the points are collinear. Okay, now we do the next problem. You are given 4 points. Show that they form the sides of a parallelogram. Show that they form the sides of a parallelogram. So the points are, so the question is, show that the points 4, 7, 8. It is 6th problem in second section. 4, 7, 8, and then 2, 3, 4, and then -1, -2, 1, and then 1, 2, 5 are vertices of parallelogram. Show that they are the vertices of a parallelogram. So how we do is, we'll take them as A, B, C, D, and then we'll find the direction ratios of all the sides A, B, B, C, C, D, and D, A. We know that in a parallelogram, the opposite sides are parallel. So if you just show that opposite sides are parallel, then they form a parallelogram. So now we'll take the sides, vertices as A, B, C, D. So let A is equal to 4, 7, 8. B is equal to 2, 3, 4. And then C is equal to -1, -2, 1. D is equal to 1, 2, 5. Now we'll write the direction ratios of AB. X2 minus x1, y2 minus y1, z2 minus z1, like that. So it is 4 minus 2, I'll take 2. 7 minus 3, 4. 8 minus 4 is again 4. Now we'll write the direction ratios of BC. See, it can be x2 minus x1, y2 minus y1, z2 minus z1, or x1 minus x2, y1 minus y2, z1 minus z2. Because they are the ratios, you can take in any form. If you take in the other way, it will be minus all. So you can take -1 as the common ratio and cancel. Even you can write this as 1, 2, 2. Common ratio 2 you can cancel because these are all ratios. Okay, then let it be BC. What is the direction ratios? 2 plus 1, 3. And then 3 plus 2, 5. And then 4 minus 1, 3. Like this. Now the direction ratios of BC. Next is CD. CD is -1, -1, -2, -4, and then -4. And then we'll find the direction ratios, the DRs. DRs of direction ratios of CD and then DA. D and A. So it is 3 and then 5 and then 3. Like this. You can see direction ratios. Ratios themselves are, so you can actually take them as 2, 4, 4 also. Or 1, 2, 2 also you can take. You can say DRs of BC and AB and CD are parallel, equal also. Yes. So we can see DRs of AB. We will take them otherwise like this. We'll take them as A1, B1, C1. This as A2, B2, C2. A3, B3, C3. And this as A4, B4, C4. Now we can say since A1 by A3 is equal to B1 by B3 is equal to C1 by C3. You can see because 2 by 2 is same as 4 by 4 is same as 4 by 4. Because they satisfy this condition implies that since A1 by A3 is equal to B1 by B3 is equal to C1 by C3, ABE and since they're equal, AB and CD are parallel. AB and CD are parallel. Again we'll take what is it? A2 by A4. A2 by A4 is same as B2 by B4 is same as C2 by C4 because 3 by 3 is equal to 5 by 5 is equal to 3 by 3 is equal to 1. So it implies that implies these sides. What are the sides? BC and DA. The sides BC and DA are parallel. Since opposite sides are parallel, the quadrilateral formed by ABCD, these 4 points are forming a quadrilateral. So the quadrilateral formed by the points A, B, C, D is a parallelogram. So it is a parallelogram. Hence it is proved. So like this we do the problem. So to show that the 4 points are the vertices of a parallelogram, you show that the opposite sides are parallel. When are opposite sides parallel? When the direction ratios are proportional. So you can just show that the direction ratios are proportional, and so they are. Now the next problem. Now we'll do the second section. First problem. If the direction ratios if the DRs of a line are 3, 4, 0, find its direction cosines and also the angles made with the coordinate axis. So here, if you remember, the direction ratios of a line are given. So in the solution, the DRs of a line are 3, 4, 0. So what are the direction cosines? You divide by root of 3 square plus 4 square plus 0 square. 9 plus 14, 16, 25. So that is 5. So therefore, the DCs of the line are 3 by 5, 4 by 5 and 0 by 5, that is 0 only. So this is one answer. Suppose that the DCs of the line are DCs, no? So we'll take them as L1, M1 and N1. So that is 3 by 5 N1, 3 by 5, 4 by 5 and 0. These are the direction cosines of the line. Now you have the problem like this. You have x-axis, y-axis, z-axis. Now you must find, so that you have a line like this. So what is the angle made by this line with the coordinate axis? This line makes, suppose it passes through origin like this. So it makes an angle alpha with, suppose that it makes an angle alpha with x-axis, beta with y-axis and gamma with z-axis. Then how to find the angle between the line and x-axis? We know that the direction cosines. What are the DCs of x-axis? DCs of x-axis are 1, 0, 0. DCs of x-axis are cos 0. X-axis makes 0 degrees with x-axis, 90 degrees with y-axis, 90 degrees with z-axis. We discussed this in the first period of this chapter. So so the direction cosines of x-axis are 1, 0, 0. So name them as L2, M2, N2. Now, if the line makes angle alpha with x-axis, then cos alpha is equal to L1 L2 plus M1 M2 plus N1 N2. These are the direction cosines. So you will use this formula. So it is 3 by 5. That's all. 3 by 5 into 1. That's all. Rest are all zeros. So it is just 3 by 5. That means alpha is equal to cos inverse of 3 by 5. Now again the DCs of y-axis. Again the DCs of y-axis are 0, 1, 0 because it makes 0 degrees with y-axis, 90 degrees with x and z-axis. So this becomes L3, M3, N3. Now suppose that our beta is the angle. If the line makes angle beta with y-axis, then cos beta is equal to L1 L3 plus M1 M3 plus N1 N3. So you'll get just 4 by 5. So that means beta is equal to cos inverse of 4 by 5. Now again, the DCs of z-axis are 0, 0, 1. So these are L4, I'll take L4, M4, N4. Then cos, if the line makes angle, same kind of steps. If the line makes angle gamma with z-axis, then cos gamma is equal to L1 L4 plus M1 M4 plus N1 N4. So that is L1 is 3 by 5 into 0 and then 4 by 5 into 0, so 0. So it is 0 implies gamma is equal to 90 degrees. So the line makes, finally you write, conclude like this. Therefore the line makes angles. What is the first angle? Cos inverse 3 by 5, cos inverse 3 by 5, cos inverse 4 by 5. Write in order x-axis, y-axis, z-axis and 90 degrees with the coordinate axis. So like this we do the problem. So these are all based on angles problems.